This screencast is going to show you two examples of how we can determine whether an element is oxidized or reduced. So a redox reaction is a redox reaction only if you have a transfer of electrons, meaning you have some element that's losing electron and the other element in your reaction is going to gain those electrons that were lost. So the most basic one is NaCl formed by sodium and chlorine gas. If I were to look at the oxidation states, this is the element in pure form, or pure element, has an oxidation state of 0. Chlorine is also the pure element, has an oxidation state of 0. NaCl, Na has a charge of +1, oxidation state of +1. Chloride has a charge of -1, so it has an oxidation state of -1. So if I'm going to look at the transfer of electrons, looking at, let's go with sodium. Sodium goes from 0 to +1. So for me, that looks like it is losing electrons. And if I were to look at, let's say, chlorine goes from 0 to -1. Looks like it's gaining electrons. So the difference between oxidation and reduction. Oxidation is when your reactant loses electrons. Reduction is when your reactant gains electrons. So if you have a species or an element or a compound, it has lost electrons, we would say that reactant has become oxidized. If you have a species or a substance or a chemical reactant that has gained electrons, we would say that reactant has become reduced. And here are two acronyms to help you memorize the difference between oxidation and reduction. The first one on the left here, this is a picture of an oil rig. So oil rig, OIL, oxidation is losing electrons, OIL. For the rig part, RIG, reduction is gaining electrons. On the right here, this is a picture of Leo the lion. Leo says grr, LEO, Leo. Losing electrons is oxidation. For the grr part, gaining electrons is reduction, GER. So you can use this if it will help you memorize the difference between oxidation and reduction. Going back to formation of salt, NaCl. Once we have determined that Na has lost electrons, we would say that Na has become oxidized. So sodium has become oxidized. And we can say for chlorine, because it has gained the electrons that sodium lost, chlorine becomes reduced. Just write red for short. If we were to do another example, such as the combustion of methane, before I can figure out what's oxidized, what's reduced, I would have to do the oxidation states. So I would go back on my list to see the difference between carbon and hydrogen. Hydrogen is on that list. Hydrogen has an oxidation state of +1. And since I have 4 hydrogens with a +1, that means carbon has to be -4, because both of these have to add up to 0. Looking at oxygen, oxygen in its pure element form has an oxidation state of 0. And it doesn't matter about the coefficients, so we can kind of ignore that in terms of oxidation states. For carbon dioxide, we did that earlier in the notes. So I'll just write +4, -2. For water, ignoring the ignoring the coefficient, just looking at H2O, oxygen in most compounds, oxidation state of -2, and that must mean that hydrogen is +1. So now if we're going to track everything, looking at carbon. Carbon starts off with an oxidation state of -4, and then it goes to +4. So for me, it looks like carbon is losing electrons, losing 8 electrons, which means that carbon has to be the element that's oxidized. So we either say that the element carbon is oxidized, or we can say the entire molecule, methane, gets oxidized. They can be used interchangeably. So either carbon, the element, gets oxidized, or typically you might just hear the whole substance, the whole reactant of methane gets oxidized. And then if we were to look at now oxygen, so oxygen starts off with an oxidation state of 0, and that turns into oxidation state of -2 in carbon dioxide, and also -2 in water. So it looks like it has gained electrons. So we would say oxygen gets reduced. So oxygen, the molecule, the element, gets reduced, and carbon, the element gets oxidized.